So I actually pulled a shirt out of the dryer this morning and found a ballpoint pen just sitting right there in the pocket.
Oh no, the classic laundry survival test.
Yeah, exactly. And it was piping hot, totally intact, and honestly, it wrote better than the expensive one I have sitting on my desk.
Right, because we treat them as these totally disposable things, you know? But that cheap pen is arguably the most sophisticated piece of engineering you own.
I mean, I looked into this for our deep dive today,
Yeah.
and calling it a system isn't an exaggeration at all,
No, not at all. It is a highly optimized micromechanical and microfluidic system disguised as a little plastic stick.
which is crazy because we're talking about space-age materials and fluid dynamics that break the usual rules of physics.
Exactly. And the whole mission for this deep dive is to unpack for you, the listener, just how much rigorous science goes into this everyday object that costs, what, less than $1?
Less than $1, yeah. So let's start with the business end, the ball.
The ball.
It looks like steel, but it's usually, well, it's tungsten carbide, right?
That's the one. It's roughly 94% tungsten carbide and about 6% cobalt.
Which is basically the same composite used in industrial drill bits.
Effectively, yeah. It's nearly as hard as diamond. Because if manufacturers used regular steel, the paper you write on, which is actually quite abrasive at a microscopic level,
You would just sand it flat.
it would sand the ball completely flat within just a few pages of writing.
But here's the really counterintuitive part I found in the research. You don't actually want that ball to be perfectly smooth.
You really don't? If it were mirror smooth, it would just slip across the ink without grabbing it.
So it needs texture.
Right, it needs a very specific surface roughness. Think of it like the tread on a car tire.
Ah, I see. So it's strictly mechanical.
Yeah.
It needs that texture to grip the ink inside the reservoir and physically haul it out onto the paper.
Precisely. Without that traction, the ball skids and your writing skips. It's all a delicate balance of managing friction and flow.
Well, speaking of managing complex flow, that's actually a perfect spot to mention our sponsor, Embersilk. We're talking about eliminating friction in a physical system here, but Embersilk does the exact same thing for digital systems.
Yeah, whether you're training AI models or you're trying to figure out where autonomous agents actually fit into your business workflow.
They smooth out that whole integration process so you aren't fighting your own tools. If you need help with AI automation or software development, you definitely need to check them out at embersilk.com for all your AI needs.
They do great work.
They really do. So getting back to the pen. The ball sits in a socket. But the socket isn't just a simple cup, is it?
No, a simple cup would just block the ink entirely. Inside that tiny brass or stainless steel tip, there are these intricate little radial protrusions.
Like tiny irrigation channels.
Exactly. Or like the rifling inside a barrel. They guide the ink right around the ball.
Okay, so I have to ask about this fun fact I've seen floating around the internet.
Oh, I know the one.
The one claiming there is a perfect, uniform 500 nanometer gap between the ball and the seat. Because that sounded highly suspicious to me.
It's a great myth, but from a manufacturing perspective, it's practically impossible. We're talking about mass production of billions of units. Trying to hold a tolerance that tight would just result in millions of jammed pens.
Right, so the ink isn't held in by some microscopic seal.
No, the gap is actually much larger, anywhere from 5 to 50 microns. The ink just stays inside because of capillary action.
And surface tension.
Right, it's just hanging on there until you apply pressure.
Which works flawlessly because the ink isn't just colored water, it's a non-Newtonian fluid.
Yes. Specifically, it's a shear-thinning fluid. And this is honestly my favorite part of the physics here.
It's fascinating.
When the pen is just sitting idle in your pocket, the ink is basically a gel. It's effectively a solid, which is why it doesn't leak everywhere.
But the moment you start writing, the physics totally change.
Exactly. As the ball spins, it creates a very high shear rate. And that physical stress instantly breaks the gel structure, turning it into a liquid that just flows right onto the page.
That perfectly explains the scribble phenomena.
The startup problem, yeah.
You know when you pick up a pen that hasn't been used in a while, you have to draw those little circles to get it working?
Right, you are manually forcing that phase change. You have to get the ball moving fast enough to shear that ink back into a liquid state.
Yeah. It really puts things into perspective. We have achieved atomic-level precision and mastered incredibly complex fluid dynamics just to make sure we can write a grocery list on a Post-it note.
It's deeply inspiring when you think about it. If humanity can apply this much incredible rigor and optimization to something so small and cheap, just imagine the potential stored in all the other tools we use every day that we haven't even begun to optimize yet.
We are so capable of solving huge problems. That is a truly fascinating and optimistic thought to leave you with today. There is always more wonder to find in the mundane and so much progress ahead of us. If you enjoyed this deep dive, please subscribe to the show. And hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.
Thanks, everyone.